Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing recursive sequences. This is standard A.12D in the great state of Texas, and we are using item number 41 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got the first 6 terms in this geometric sequence here, and they just tell us that a to the 1, right, equals that -4. So if we wanted to kind of fill this out, we can say a to the 2, a to the 3, a to the 4, so on and so forth. And we're supposed to find some type of equation that can help us find the nth term, right? So if we wanted to find the 10th term in the sequence or the 18th term in the sequence. And so that's where, when we see patterns like this, right, we see 4, -4, -16, right? Our initial thought is, oh, that's easy, that's multiplied by 4, right? 16 times 4 and 64 times 4. Technically that is correct, right? We are going to involve a 4 somehow. But that doesn't help us find the nth term in the sequence, because if I wanted to find, let's say, the 97th term in the sequence, how could I find that without literally finding the 96th and then multiplying that by 4, right? Right now, if my only information is it's a times 4, I've got to go all the way from A6 to A7 to 8. I've got to go all the way up, multiplying by 4 to find the 97th. There's got to be a faster way. And so that's what we're looking at in this problem. And so we are going to deal with a 4, right? So let's think of what is another way, because that multiply by 4 doesn't necessarily bring up this sequence right here. So what's going on with this number 4, right? This number 4 that we're dealing with here, and then the term in the sequence. Well, if we multiplied 4 times n, okay, so that would be 4 times 1 for the first term, gets us 4. We'll deal with a negative in a second. That works. But if I were to say my n is 2, the second term in this sequence, you see, is supposed to be 16. That doesn't work. All right, so simply multiplying 4 times the term in the sequence is not going to work. You see, that third one is supposed to be 64, but it only makes it 12. But really what I'm not doing is I'm not multiplying it by 4. I'm multiplying 4 times the term in the sequence. And so let's see if we could do something else. We need to multiply by 4. But you know what I see? I see some exponents. Okay, so let's try taking it to the n power. All right, so we got an exponential growth here, possibly. So 4 to the 1 is going to equal 4. Okay, that works. And then 4 to the second power means 4 times 4. Oh, I like that. That's going to give me 16, yes. 4 to the 3 is going to be 4 squared times another 4. Okay, so now I'm getting my multiplying by 4. If you just multiply it to the n power. Okay, so 256. All right, so we're good there. But now we need to deal with our negative, right? Does it go on the outside or does it go on the inside? I need to end up every single term with a negative. Watch what happens if I do this right here, okay? So -4 to the 1 power. We're good. So that's going to be -4. But watch, if I go to the second term in the sequence, to the second power, -4 times -4 ends up as a positive 16. And I'm not needing a positive 16. I'm needing a negative 16. So it's going to make every other term actually positive. So if we have a negative sitting on the outside of this, let's try that -4, and let's take it to the second power. So first order of operations, we multiply the exponent, that's 16, and then we apply that times -1. That gets us what we need, and our answer is B.